Welcome to In the Loop, a New England Temperature Solutions podcast. In today's episode, NETS President Dominic DeLuca will be interviewing Fluke Industrial Process Solutions Northeast Regional Sales Manager Greg Secord on infrared applications. Greg has been the regional manager for Fluke, Raytech, and Ircon since 2009. Without further ado, here's Dom and Greg helping you get in the loop.
Hi, I'm here today. I'm Dominic DeLuca, President of New England Temperature Solutions, and I'm here today with Greg Secord from Fluke Process Instruments. You say hi, Greg.
Hi, Dom. Hi, everybody.
And where are you sitting right now, Greg? What part of this lovely fruited plain?
I am sitting in sort of downstate New York, you might say. So the heart of my Northeast territory.
Okay, and you are the Northeast Regional Outside Sales Manager for Fluke. And
That's right.
You are a New Yorker. So what teams are we competing with here?
You know, I root, well, let's see. I know you're going to go baseball as a Red Sox guy, but I can't say that I don't follow. I don't care too much about baseball. As a child, I was a Yankees fan. But you know what? I root for the only football team that really plays in New York, and that's the Bills.
Oh, the Bills. Okay, well, that's a good rivalry. They're not, but I hate baseball too. So I am not. It's the most boring sport. I tell people if you could tackle a first baseman on the way to second, I'm in. But I'm actually a more dangerous sport. I'm a Yankee hater because I'm from New York. So I have a lot of relatives. I can pull their chain with the Red Sox rivalry there. But So
all the time I've known you, I never knew you're from New York. I've got to dig into that sometime.
Really, yeah. Long Island, born in Long Island. Billy Joel my grandmother served Billy Joel. That's my 5 microsecond of fame, I guess. So
that explains a lot.
Yeah, and I spent summers in Queens when I was a kid. I remember watching a car get totally stripped and not knowing why. 30 minutes later it had no tires on it. But it was also in the 70s when, all the gangs and everything were in New York. But so you live in New York, you cover the Northeast, and you sell for Fluke. So let's start with Fluke has not always been a name synonymous with infrared, at least in the industrial market space. So tell us how we end up with a Fluke pyrometer today. What's the history?
Yeah, Fluke. What everybody knows so well as Fluke is the kind of the yellow, like this symbol right here. You see it all over a lot of handheld test tools, and these are portable, battery-powered things like multimeters. Obviously, The Fluke multimeter, people just call it a Fluke meter, like you call tissues Kleenex.
Yep.
So it helps with name recognition. You walk in, they know Fluke, but they don't necessarily know the products that we bring to it. One of the things, or two of the things that Fluke has in their handheld versions are laser distance meters, of course, but they have infrared temperature sensors. They have also handheld thermal imagers. Well, we have in Fluke Process Instruments the fixed version of both of those. When I say fixed, I mean you'd install it kind of permanently, feed like DC power to it, connect some outputs, and you can monitor around the clock either a process or an area that you're worried about monitoring for safety or whatnot. That's what separates us. That's what makes up Fluke Process Instruments, at least the part that we work in. And those were really made up of two companies, both American companies previously that were acquired by Fluke, and that's Raytech and Ircon. And both of those brands, they're pretty well-known brands even during the time that Fluke owned them. So Fluke acquired Raytech even before 2000, before I was even involved. And then they acquired Raytech not long after, before 2010. So both of those companies for 15, 20 plus years have been part of Fluke, even though those brands have continued to be, kind of favorites and out there in the market. But of late, you'll see, we'll talk about these pyrometers, but the newer instruments that we're releasing are branded as Fluke Process Instruments, and those are kind of replacing the legacy ones. But it's still really the same people, a lot of the same engineering, and even the same factories that have always made these Raytech and Ircon products.
Okay, yeah. And I remember I've been selling Fred for a long time, since the 80s, and company wasn't Ircon or Raytech at the time, and Ircon was well known in the industry. Raytech seemed to come a little later, at least to my knowledge, and then I did work for a rep for a year, and we sold Raytech was the product we sold, and then went back to selling what was Micron at the time. And about, 8 years ago, we became the Urcon Fluke Raytech rep, and it's been a great run for us. So those are great products. Urcon, Raytech, just been around for a long time now. All the new stuff, as you'll point out, is going to be labeled Fluke. So we have a wide range of products from low cost to high cost to imaging and scanners. So why don't we start? What we hope to do today is just kind of go through the different products and maybe where a couple well-known uses for each of them, and maybe what sets us apart from the others that might be out there. So let's start at the bottom. So we have an entry-level offering. Why don't you tell us a little bit about what that is and what it does?
Sure. Yeah, we have a whole series we call our Compact series. It's made up of a few different products, but if you start at the most simple things we have out there, these are still branded Raytech, by the way. These are Raytech products. We have a CI and a CM that are very similar. The CI is older. The CM came in and had a few different features, but I think the CI was popular enough and had a few different niches where it was the best product, that we kept them both alive. And so these have been around for decades. They're as simple as you can get. They're about 3 inches long. You just power them with some DC power. They'll output, by default, you would get a 0 to 5 volt linear output like a typical transducer. But what a lot of people use is they also have the ability to have a type J or type K thermocouple output. And it's not a thermocouple, of course, but it's going to give you that nonlinear output relative to temperature that a thermocouple has. And so the idea is if you already were measuring something with a thermocouple, you can take that out, pop one of these in there, enjoy the benefits of a kind of a longer lasting IR sensor without the contact needed, and get the same output, so you don't have to change your recorder or your control system that was having the input from the thermocouple before.
I did now, just bump into an issue where, and I'm not going to ask you the question. This would be a tactical. It's a hard question to even know the answer specifically. But we had a customer using something like that with one of our controllers, and it turns out that the impedance on those things are a lot higher than a thermocouple would be, and Eurotherm had trouble doing it because it did not have a high impedance input. So just a footnote, if anybody decides to do that, to make sure your controller, your input device can take it. But go ahead, continue. I didn't mean to interrupt you. It's kind of early in the morning.
Not a problem. And I mean, you're probably like me. I mean, with the CI and the CM and even the MI3 that I'll talk about in a minute, I really don't talk to customers about those nearly as much as I talk about the kind of lower volume, higher end instruments out there, because it's a lot of times it's pretty self-serve. People have maybe designed them into the machinery that they make already. Right. And it's kind of set it and forget it. These guys self-serve, buy more when they need them. And they've worked with we've got a great tech support team that has worked with these things for years and years and can help those guys when they need help. So it's pretty simple, and these kind of go by without me even seeing them. But I think the MI3, the next one I'm going to talk about, I think we've sold more of that pyrometer than we've sold of any other pyrometer that we make over history. It's been around for decades, and we sell, many hundreds or maybe thousands of them is the right word. So the MI3 in the Compact series, the MI3 is kind of king. That's what we sell the most of. Mm-hmm. And it's also the most compact. I think in our older documentation, I remember seeing that this was billed as the smallest infrared sensor on the market. And maybe it is, or maybe it was. I'm not sure if it still is, but it's got to be pretty close. It's about the size of the tip of your pinky finger. Mm-hmm. And it's about a little bit over an inch long. There's almost exactly an inch long. And then that little tiny sensor head is connected to a cable. And the signal that goes through the cable from the sensor head is actually a digital signal. That's kind of important, because then you don't have line losses that you might possibly have if you had like a voltage output or something. So you have a cable, you can define different lengths, and that cable runs to a little separate comm box. So it's a 2-piece system. That's a communications box on the other end. And that box, it's pretty handy. It has a little LCD readout on it. So this system will have a little head that you can install almost anywhere because it's so small. Runs back to the box where you want the operators to be able to get that readout. And that might be all you need if you just want to get a visual indication. But also that communications box offers you a bunch of different outputs. So you can have Ethernet digital output, you can have RS-45, you can have analog output, whatever you want to take into your control system or your recording system out from there. So that system is very convenient, where you can't mount, a lot of times a pyrometer is, this big, and it's tough to fit into a system. If you take one of these little compact sensors, you can fit it almost anywhere. you'll find there's certain features that the high-end sensors have, especially sighting. Most of these little low-temp sensors don't have any, laser or anything else to tell you exactly where you're pointing. And so that's why you might move up the chain to something else. But for a lot of applications, they offer almost everything you need in a pyrometer at a pretty low price.
Yeah, I think where we bump into having to jump to the next level is temperature range too. Although these you can get these really hot. I'm surprised at how hot you can get it without cooling. And the other cool feature that I know we've sold is there's a multiplex box where you can put a bunch of them on one box, and then it goes off and goes to another device. So there's some pretty good, for an OEM, he's got a machine that wants 8 of these on it. That was the application we had. It was a pretty cool device. Yeah. And you get cooling, right? You got options cooling and all that with it.
Yeah, you can get air cooling connected to them. You can have a little purge line. So a lot of times the area is so dusty that it will coat that lens and start to decay your signal. But you can have an air purge there that blows it off and keeps it clean. So it's almost all the features that you have in our pyrometers are available in these. It's kind of funny, for a very low price, you can do quite a bit. But like you said, you get into not only higher ambient temperatures, but higher temperature ranges. If you need to measure thousands of degrees, you're moving up to something else. If you need different wavelengths, and we can talk about why you might need different wavelengths than they offer in those, and you might want the sighting and things like that. So there's features that drive you upward from there, but they measure very well.
Yeah, that's typically right. The optics add money, the temperature range adds money, the features of wavelengths add money, and this one, I the spot size is pretty big the further away you go. So if we're looking at the average spot of the side of a big device, we're fine. But if we're trying to get a small spot, we're not. And
precisely.
So we bump into an application and it's single color, and it's we can't, because of optics or whatever, we can't. What's the next level of controller of sensor that we have?
Yeah, the next level up is kind of our mid-range. I think of it as kind of a workhorse sensor because it's still pretty economical, but it has almost every temperature range that we have, and has almost every wavelength that we offer available, and that's the ThermalAlert 4.0. And sorry for using props, but I got to show you. I happen to have a couple of these sitting around. So this is what a ThermalAlert 4.0 looks like. I think we're talking about 7 or 8 inches long, about an inch and a half in diameter. Still fairly compact, but when you consider everything is in there, that's all you need. In the old days, a pyrometer would always have a head, might be actually in the old days a pretty large head, a wire, and then a big box on the other end that has electronics. Well, these days, everything's all in the one piece, and that's all you need is that one piece. It'll output to your control system. It'll, it can digitally interface to a computer. It can do whatever.
And in the old days, it was like $10,000 too. I mean, it's crazy how some of those microns with the 3 pieces were $10,000-$12,000.
It was reverse inflation, I guess, on some of these. Actually, for some of those older sensors, you're well aware of these Zircon sensors. You put them in, and they'll run for 20, 30 years, and then these guys pull it up, and they're not the guy who bought it. The predecessor before the predecessor installed these, and they go to replace them. But if they know anything about the last time they bought them, they probably paid $5,000, $6,000, $7,000 for the sensor, and we say, well, we've got a good replacement. Here it is for a couple $1,000.
Right. So this is between 2 and 3.
Should be pretty pleasant surprise. Between 2 and 3 for most of them, unless you get into some really the more strange ones. You can maybe top 3, but about 2 to 3, even less than 2 for the simplest ones.
Yeah, and then the cooling jacket, depending upon what you get, could be expensive too. So, but pretty much that's been the price range.
I want to point out, this kind of ties into that legacy of where Fluke Process Instruments came from, is that, when we were carrying those lines, when we had under Fluke Process Instruments, we had Ercon, we had Raytech still going on for quite a while. Historically, we had Modline 3 and Modline 4 and Modline 5 all in that Ercon range, and we had a whole bunch of different Raytechs along the lines as well. This kind of replaces a couple of different models, one from each brand, and that was the idea, Is a company going to really effectively maintain and bring up to modern standards both product lines at the same time when you have a lot of redundancy between them?
Right.
And Fluke decided it was smarter not to, even though those brands held a lot of weight. So what we've done is taken essentially the Modline 4, which had a ton of wavelengths, usually a 2-wire loop power kind of output, and a lot of different ranges in that series. And then the old ThermalAlert series from Raytech, which made up the TX, and add also the XR in there, but a lot of TXs are out there in the field. And both of those are broad and easily could be replaced by the Modline 4.0.
Mm-hmm. And so
that's the point.
That's great, because we have a controller like that. We have two controllers. Watlow bought Eurotherm, and there's these two controllers that they have that they both lack a couple of features. One has features the other one doesn't, and vice versa. And we're like, put them in a room, let them have a baby, and come out with one with everything. And you guys have actually done that, which
That's
is
exactly
great.
what we did. We did it at this level, and we did it at the next level up, which we can talk about. But, Ercon had these kind of bulletproof enclosures. The latest ones were made out of stainless steel and really good in the tough industries like steel making and, foundries and things like that. And Raytech, we've chosen the package or the size and shape of the Raytech. So if you look at an old TX, this Modline 4.0 is a direct drop-in replacement. You literally could take one out, put the other one in, hook up the wire, and go. And you can do that a lot with the Ercons as well, with the accessories. So we've done a lot to make sure that they're backward compatible with almost anything that somebody has.
Yeah, so you have a cable, right? You have an adapter on one of them where you can use it to get the same output. And the boxes, if it was wired to an old box, that's not going to work. But certainly to a controller with 4 to 20 out, you'll have the connections and the power there.
Yeah, where you had one of the one-piece sensors like a Modline 5, you could just do a quick cable adapter. When you have the loop power sensors, those are very simple 2-wire thing that could go into either one of these. And so, you could take, a lot of times it's a couple $1,000 to put in the pyrometer or to buy the pyrometer, but then to run the conduit and get an electrician and pull cable through there and rewire it and maybe get a new power supply, that can be much more of a headache than the pyrometer itself. So if somebody can replace it without all that headache, it's great.
Yeah, that's a huge competitive advantage too, price-wise. Yeah, because the cost of installation is a lot of times as much, if not more, than the cost of the sensor. So we've got some cool wavelengths. What are everybody uses 8 to 14 typically on a single color. What are a couple of the other ones that we have that are unique, and what are they for?
Yeah, I'll explain. I'll try to explain a little bit of what they're for. So 8 to 14 microns or something very similar to it is what a lot of what your general purpose pyrometers and handheld IR sensors are for. So when people say, I'm going to go get my gun, which a lot of times it's just a handheld temperature sensor, IR temperature sensor, they'll take that thing and almost certainly it's operating right in that wide band and long wavelength of about 8 to 14 microns. And it's good for general purpose stuff.
We all got exposed to that during COVID, right? Those little cheap things that they put on our heads were probably more like 5 to 20 microns because they weren't that accurate. But yeah, that's pretty much what it was, right?
And, you can. I just was at Home Depot the other day. You can find them on the shelves there of some sort of caliber. You know what I mean? Less than $50, I think you can get one. But
crazy.
Even you can get a Fluke one for a couple $100. It might be a little bit better of a product, but it's still very general purpose. So we have that type of range, and believe it or not, we call those LT or low temp ranges. But low temp to us means often up to about 600 C, or some of the low temp models will go up to 1,000 degrees C. Which, if you think about it, it's 1,800 degrees Fahrenheit. That's not really low temperature at all. But in the span of what you can do with IR, it's pretty low. And I think the reason we call it low is that the low end of that range starts out about ambient or even negative in some cases. So it can do your low temperature application.
Plus the ones you buy at Home Depot, if anybody's tempted to use them in process, they have a huge spot size. I mean, they're designed to be an inch away from a circuit breaker to do a hot spot. They're not designed to be a few feet away because you'd be looking at the whole panel or the whole, If you hold this thing 5 feet away, you're going to look at everybody's head, not just mine. And emissivity is an issues with those, so that's why I had issues getting my temperature taken because of the shininess up there. But go ahead, continue.
You're too low emissivity.
Yeah.
That you were right in that what you pay for kind of is the optics, and that's invisible. When you look at the outside, the package looks the same, but what a lot of times drives that price as you get into the upper levels of performance is you have optics that could be 10, 20 feet away and still have a nice small spot size so you can look at something like a pipe or something that's not, a mile wide. So about the wavelengths, and I think we have 10 different wavelengths offered, somewhere around 10 different wavelengths offered, maybe more on the Thermalure 4.0 series. And the reason we have that is not only because it kind of does relate to the temperature range. So the shorter wavelengths are used for the higher temperature ranges. So for the metals and ceramics and carbon In semiconductor applications, we use 1 and 2 microns a lot of times, sort of because of the range, but for other reasons too. But there's also very specific wavelengths that we use. And, and what I mean is the sensors will pick up radiation at a lot of different wavelengths, but they apply filters over those sensors so that we're only taking in radiation in certain bands of wavelengths. And the purpose of doing that is that the materials that you want to measure, specifically stuff like glass or plastics, really thin films of plastics at times, sometimes it's really challenging because at certain wavelengths, glass is really easy to envision because in the visible spectrum, of course, glass is transparent. So if you aimed a pyrometer right at glass, if it's a low wavelength like our visible spectrum is, you see right through it. And so you're really measuring what's behind it. And it's the same thing with certain plastics and especially thin layers as well. But if you look at a spectrograph, and I mean, you can Google this stuff. It's something I never did, but in the last 8 years since I've been doing this, I've done a lot of it. You can Google the optical or spectral graphs of these materials, and you'll see that certain, like plastics, for example, will be really transparent and transmit radiation very well at some wavelengths. And then at certain wavelengths, right around 3 or 4 microns, you'll get a very opaque, very high level of emission and also absorption of radiation. So that means if you measure it right in that wavelength, you're not measuring what's behind that plastic sheet. I mean, you can measure like a Glad bag, a very, very thin piece of plastic. And with certain wavelengths, you'll look right through it. With certain wavelengths, you'll see it. And so it's really important to understand. I mean, that's where you and I come in, I guess, is
right.
Talking to a customer. What are you trying to do? And let's make sure we get you into the right pyrometer to do it.
I remember I had an imager. It was 8 to 14, and I have an office, and in my office, big giant window looking out at the street, and I took a picture, and what it was a perfect infrared image of me reflecting in the window. It didn't see through the window. It was as if it was looking right at me. It was a pretty cool example of what
precisely
8 to 14 doesn't see through glass, and then it becomes our friend at 1 micron because a lot of the high temperature stuff is behind a quartz window. And 2,000, 2,500, we go to 3,200. Have actually had an application higher than 3,200 C because it went above the range, but those have to be behind glass, and the 1 micron looks right through it. So continue on.
Yep. I guess that's about it, really. I think that the thing about these thermal alert 4.0s is you have all the features you want for these applications we're talking about, but nothing that's going to really add cost that you don't need. And so you don't have a local display of temperature. You have a signal that's going out either digitally or analog to wherever you need it. And most people are installing these on a system where they just want to read that output into a PLC or something like that. So if you want to change settings on there, there's no local menu. There's no local display, but you plug into it. Nowadays, what you do is you plug into it with a USB. It has a little mini USB connector on there. We have free software on your computer. You connect up to it, change your settings to what you want them, disconnect, and it'll just continue to output. So it's, you're able to do everything you need to with it, but we're able to keep that price below a few $1,000 by just the stuff that you need. But now we have ranges that go up to 3,000 C even on these because we have the very low wavelengths, but they're still single color.
And the people might think, I have to change it all. Well, these are generally set and forget. I mean, when you get it, you apply it to the process. You set it and it's done. People are. I mean, emissivity maybe tweak it, but as far as ranges and outputs and all that, that's once that's done, it stays there until you've retired and the next person comes on and wants to change it and doesn't realize it. So now we're going to step into our endurance. I'm assuming that's our high end single spot.
Yep, and I guess if we're show and telling, I'll show and tell one more time. So we've got one more package that gets slightly bigger, but we're still talking about a cylinder here that just does everything in one package. On the back now, we've got an instrument panel, so you can see you've got a way to read the temperature locally. You've also got a little window. It's hard to see there, but you also got a little viewport. You can look right through there, see where you're aiming, and you got a little, it's almost like looking through a gun sight or something like that. You can see exactly where your spot is and how big your spot is. So there's several different ways to sight and aim the pyrometer now that there weren't before. There's local display of temperature. You actually have a full instrument menu on there, so you can change all the settings of the pyrometer right there locally. And then you have 2 different outputs on every one. You don't really have to choose. You have a digital output a digital connector and an analog connector. So you can have RS-485, you can have analog output, you can have Ethernet output. And, with some options there, you can add things like Ethernet IP, which a lot of people want to do these days, or in Europe, you'd want to do Profinet. I think it's pretty popular. So you kind of have all the outputs available to you. You also have all the sighting choices. And so I'll describe that. That means that, if we're trying to look at something small, we want to make sure we're aiming right exactly at it. You can look visually through the back of it, but, if it's mounted on top of a furnace, you're not going to climb up on top of the furnace and look down through it. So you have laser out the front to show you where you're aiming like you do on a lot of units, but you also have an option for an LED. LED is a little more functional than the laser sometimes because it shows the actual size of the spot size. So if your spot size is measuring 1 inch, your laser or your LED dot would actually be 1 inch wide, whereas your laser's just in the middle of it. And then kind of the best thing, if you have a computer around or an HMI that can integrate this, is you have a video output. And it's not really for taking videos. It can record video. It can monitor the process. But the main thing is it's a great way to see exactly where you're aiming. So you've got a reticle or a circle shown, shows you exactly where the spot is. And it's really easy to adjust and make sure you're aiming where you want to be. And somebody could monitor that. It's coming over Ethernet. So you can monitor that at your control system or at your desk or anywhere, or just on a laptop during setup. So a lot more features on the Endurance.
We had an application where the furnaces would as they get hot, the tube would sort of bend and things would move. I mean, imagine how much expansion there is in 2,000 degrees.
Wow.
So, and if it didn't look like a full moon, they knew that it had moved. So they knew there was an issue, and that makes for the spot size changing. It also, you could start looking at the tube and start getting just erroneous readings. So the camera has been a really cool feature for us. The other thing is the reticle. You can talk maybe more on this. Is actually the detector size, right?
Yeah, it truly shows you the size. If I've got two different models that have different optics, one of them will have 100-to-1 optics. We talked about that's if you're 100 inches away, you get a 1 inch spot, and that would make it 100-to-1 optics. Well, some of the models have 300-to-1 optics. And if you look through the back of it, you can tell the difference. The reticle on that 300-to-1 is tiny, and you could be truly across the room and still measuring something pretty small.
Right.
People ask, it's a really common question. It surprises me, but I guess it shouldn't. People ask, how far away can I be? How close do you need to be? I think the assumption is that signal, like if you're 3 feet away, it's just fine. But if you're 20 or 30 feet away, there's a problem, and it's not going to get that signal. Well, with pyrometers, for one thing, they don't make them in the range of 4 to 5 microns usually. And that's because all the stuff in the atmosphere, the water vapor and the CO2 and everything like that emits and causes problems or will eat up your signal if you're looking through those. But at the wavelength we operate, it really essentially it's like going through space. That signal is going to be just as strong 100 feet away as it is right in front of you, so long as you don't have a bunch of dust or particulate in the air blocking it. But the only thing that you suffer from is that your spot size will keep getting bigger as you get further away. So as long as you can get the spot size you need, you can position that pyrometer where you want. And that's important. I mean, if you got a vat of molten steel and you've got cranes coming in and out and operators working there and everything, you don't want to have that thing right in the way. You need to have it safely out of the way and still getting that measurement.
Yeah, I joke. The customers ask me that question all the time, and I say, "Well, I could point it at the sun and give you the temperature of the sun." I mean, it just works like that. The other thing too with the reticle being important is we have if it's really small, the two color says you only need 10-20% of the target, and we deal with this on another podcast where I go over the two color and the two wavelengths and looking at the difference of emissivity and all that, but the reticle will tell you, like I was looking at a light bulb filament, and you can put that little circle right on the filament, and you've got a high percentage of target filling the field of view to make sure you're getting, you're within that threshold.
Yep. I mean, what's a two color and why do you need it? That's a big question. I don't know if you want to delve on into that.
We addressed
right
that
now
in a different podcast. No,
Okay.
we don't need that. This is about a product overview, so that's fine.
All right, cool. Well, that makes things a lot easier. But, that's one of the big reasons people would go into the Endurance series. Not only are they really focused in that very high temperature range, but you can get the high ranges in the Thermal Art series as well. But if you need a two color and there are a ton of applications where you do need it or you want it, you'd have to do that in the Endurance series. That's the one that we have that has those.
Right, and two color versus single color is dealt with on another pyrometer. a podcast, I should say, same thing. So let's jump now to, we've got two types of imagers. Really, we have a scanner and we have a thermal imager, and we have two versions of the thermal imager. The new one is significantly different, at least in my mind.
Yeah.
Could you give us a 30,000 foot view of why you'd use a scanner versus an imager, and then the difference between the two imagers?
Sure. One of my coworkers, he came up with the simplest. It's fit for like a kindergartner view of what we offer as a product, and he usually walks into our customers and starts with that. And I thought, it's so simple. Why not? It makes a lot of sense. We